afternoon, everyone. I think it's afternoon. I'm Shankar Ramamurthy, founder CEO of Virtual Power Systems, and with me here today is Ankush, our VP of BizDev. I'm going to talk about Virtual Power Systems. We are a software company, a 3-year-old company, started in 2013, a 20-people company, just started commercially deploying our products with a couple of large customers in the US. The problem we solve for data centers is power is going to be one of the most critical constraints in growth of data centers. Power is simply not available, and adding power infrastructure is very expensive. We solve that problem, and we solve that by unlocking currently unusable power capacity. Very much similar to the way in which this was done by virtualizing compute, storage, and network, where you had very low utilization of resources of compute, storage, and network. You virtualized them, had these resources commonly shared across multiple applications. We are doing the same thing with power. And the way we are doing it is, if you look at a power infrastructure in a data center, you have a 10 megawatt data center, only 30% of your power is actually being used. And the reason why you have such a low utilization is you need to reserve power to serve peaks. And you have spikes, and sometimes you don't even know how large those spikes are going to be. And then you want to make sure that even if there are failures that are taking place in terms of power availability in a grid, you want to make sure that power continues to be available to your IT workload. And then you have optimization that is taking place of how resources are allocated to various applications in the racks, but they don't take into account the power availability and power optimization. So these are the sources of rigidities that result in very, very low utilizations of power in data centers. And what VPS does is to systematically tackle each of these issues. So we have basically multiple control knobs, and what we have is a sensory network that is collecting data at a very granular level across the data center, and it's processing in real time and figuring out decisions that have to be taken. And the important thing about what we do is we take a decision about how power budgets have to be allocated and dynamically actuating actual power distribution. So we are controlling the power systems there. And what we have right now is a system that, if you remember the peaks we talked about, we have the capability to do the peak assurance. That's what we do today. That's the product that we have released, and our roadmap calls for the other product control knobs evolving over the next 1 year or so. So we are a software company again, but we rely upon working with underlying hardware that you see in red, and our software stack is in the blue. Just to give you an idea of what this looks like, this is like a plug-and-play system. So you have a 10 megawatt data center that is running out of power. You go and install a piece of ICE hardware, and boom, you have an extra available power capacity. So this is instantly available power capacity by merely installing the ICE hardware. Our intelligence is sitting in the data center that you see as a server on the right-hand side. This is just to give you an idea of the peak shaving. What you see here is a typical ill-behaved version of power use in a set of 4 racks. This is in a very large data center. And what you see on the right is very much like a hybrid car. We are basically shaving the peaks. We are complementing power with batteries, and that's the hardware we were inserting. We are complementing power with the batteries, and therefore we are now in a position to say, instead of supporting 4 racks, I can lower the peak and support 5 racks. So that's what we do. And we have found studies, for example, with one of the largest co-location data center that is now deploying our product. Just by inserting this, we were able to increase their capacity utilization by about 25% or 24%. This is very big, because if you look at the average cost of a data center power train, it's about $10 million a megawatt. And to be able to save 25% capacity with just one software control knob is about $2.5 million of saving right off the block. So this is just to give an idea of how that savings works out. You got about, let's say, a data center that is about 10 million large. looking to add about 5 megawatts of additional power, would typically go and build a new data center costing about 50 million. With VPS, it's about 20 million because a typical megawatt would cost only 4 million, and most of it is in terms of software. So the capex saving that results is about 30 million from this. 30 million from this, and you have, because you're now running the same data center at the same cost, without increase in operating expenses, you end up saving about $4 million a year. So these are very large savings that we bring about. So this is an important aspect of how brownfields would be able to easily assimilate what VPS offers. Similarly, in a greenfield, the savings turns out to be much larger because you can actually optimize the kind of architecture that you would end up deploying. What I would like to do is to have Ankush come and talk a little bit about the kind of customer experiences that we have had with deploying our products.
Just to give you a flavor of how we're segmenting the market and some of the actual data center operators that we're working with, I put this slide together. The way we're segmenting the market is enterprise-owned data centers, co-locations that basically rent space and power and cooling to tenants, and then hosting providers. And so one of our marquee engagements underway right now is with a company called CenturyLink. They're a Fortune 500 company based out of Louisiana, actually, and wireless and wireline telco, and they have a massive co-location footprint, 57 facilities, 50 plus megawatts across that. And so essentially with CenturyLink, the use case was they have a facility where they actually are unable to roll out any more workload, and our solution immediately allowed them and the constraint was obviously power. They were looking at other ways to kind of provision extra power that were far more expensive, and we came in at the right time and gave them a solution to roll out IT here and now, and for them that's very important because that equals revenue. So we were able to put a closed loop ROI on it and get the deal started. So we're also working with a company called IIJ in Japan, and so we're getting interest across the board. Rackspace, which is a large hosting provider based out of Texas with a nationwide footprint. And so, so giving a flavor of that. Here's a quick view of the team. We have a great team. Of course, Shankar, our fearless leader, and we brought on Amol Mahajani. He's our Chief Development Officer, who oversees things like all of our engineering around hardware, software, etc. And Kareem Sheikh, our CTO. Nikhil Sharma is our SVP of Solutions. So he's out in the field working with, on the actual deployments with the operators, ensuring the success of those deployments from POC onwards. Myself, generating business, and Craig, who works directly with Nikhil. So thank you.